Hello, everyone, and welcome to Advent to Code Day 11, 2023. We're a few minutes behind, but we're going to go ahead and jump right into the problem. Cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. The image includes empty space and galaxies. For example, the following. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. So these rows and columns need to be twice as big. The result of a cosmic expansion therefore looks like this. Okay, that makes sense. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. In these 9 galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies using only steps. Move up, down, left, right, or right exactly 1 or pound at a time. Let's see. The shortest path between 2 galaxies is allowed to pass through another galaxy. Okay. For example, here is one of the shortest paths between 5 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. I guess 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let's see. The 8 locations marked with a pound plus the step onto the Galaxy 9 itself. Here are some other examples of shortest paths. So, all of that. In this example, after expanding the universe, the sum of the shortest path between all 36 pairs of galaxies is 374. Okay, so expand the universe and find the shortest path. So there's 2 steps. We observe, and then we say, okay, anything that doesn't have a thing, we need to double it. So we add more rows and more columns. And then we have our actual observation that we're going to analyze, and then we need to find the shortest path between all what is that, 9 choose 2 pairs. Let's see. So shortest path, we can walk however we want, it seems like. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, right. Exactly 1 dot or pound at a time. Is the minimum distance not just going to be the Manhattan distance between the 2? Like, I'm pretty sure that's all it is. Let's find out. So we start with this. And we need to look at rows and columns that are empty. So if not in item, actually, let's do it this way. For I line in enumerate text for J cell in enumerate line. If the pound symbol is not in line, print I. So it's just 2 rows. Yeah. So 0, 1, 2, 3, and 7. And so we want to double. I think we could just insert we could insert just a line of all dots at the I spot. So empty rows equals blah, empty rows dot append I. For that might be a problem. Let's not do it that way. Let's do expanded universe dot append line. Do that twice. Well, actually, we do it this way. For item in expanded universe, print item. Uh-oh. I goofed. There we go. So yeah, that looks good. Now we have to do the rows, or the columns, I mean. How do we want to do that? I wish I knew how to transpose. NumPy array would be nice right now, probably. Let's think. So we want to check to see if a column is empty. Think. Because if I just start adding things in, I wish this wasn't so tricky. Why am I having such trouble with this? I just want to transpose, but I don't know how to do that nicely. If I transpose it, then I can just do the rows again. So if I turn this on its side. Oh man, think hammer. Turn it on its side, do the thing, and then undo that. All right, let's see. Let's try and learn about NumPy arrays real quick. Because my brain is not working. So, port NumPy SP. Grid equals np dot array text. I think that's. What happens if I do this? That's kind of a mess. I do this. Cool. I add rows to a NumPy array in a concise way. Maybe learning NumPy on the fly isn't going to be a good idea. Let's just go back to what we were doing. So can if I want to how do I want to do that? Can I move this over here? I can. That's nifty. Let's see. So we want this to be so this many rows and this many columns. So we want for x in len So this has 2, 3, 5, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. Okay, cool. So it has that many. Okay. So then I believe how do we want to do this? These are just a string. Why am I so bad at this sort of stuff? I want this to be a string of length. Okay. So we want to do what? We want expand universe transpose at I. I think we want this to be a JI. IJ. I don't think it's IJ, is it? Join list of strings Python. Question is, did I transpose this correctly? And the answer looks like no. I am so bad at this. Whatever. We're gonna start this over. Gracious. Why am I so trash? Let's see. Think. I'm getting stuck on the stupidest parts. And it's so frustrating. AML, thank you very much for the follow. Let's see. We just want to check to see if the freaking columns have just dots in them. So we're looking at a... Here, let's do it this way. for j in range len this at 0, for I in range len this. We want to look at if expanded universe at 0 for ij is not equal or is equal to empty equals false. If empty columns. Two, 5, 8. Did you tell me which ones are empty? No. Here, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we want to add a dot at each of these. But then when we do that, that's going to increase all of these. So I think what we want to do is for column offset equals 0, for column num in empty columns, we want to do what? We want to look at for I in line in enumerates expanded universe. Expanded universe at I going to be equal to expanded universe at I. Then we have to splice this up. We want it to be up to the column number plus a dot plus and then this needs to have the offset. Is this remotely what it is I'm supposed to be looking at? I think so, actually. Wow, that took entirely too long. That was so silly. Okay, that looks good. Okay, that was entirely too much for something so straightforward. Okay. Now we have to do the actual math. For I line in enumerate expanding universe. For J cell in enumerate line galaxies. If cell equal that, then galaxies dot append comma J. We have 0, 4, 0, 1, 2, 3, 4, and then we've got so on and so forth. Okay. So I'm pretty sure we're just looking at the Manhattan distance between all pairs of these things. We want this, that. So for I in range Lin galaxies, for J in range, oops. Uh-oh. Why are my lights turning? 1 second. Sorry about that. Something tells me that I'm not going to be able to brute force this. Because I feel like I'm brute forcing it. So we want this. So it's 1, 2, 3, 4, 5, 6. So it's pretty sure it's going to be think. I need math for this. I think I need math for absolute value. I can't remember. No. Built in. Cool. Absolute value of A at 0 minus B at 0 plus absolute value of A at 1 minus B at 1. I don't think they're ordered at all. I would think that they're ordered the same way that they have them ordered. So 1 and 7. Yeah, I'm pretty sure this is right. Going the wrong way. Kill these desktops. Yeah. All right, let's see. Can I run this on Sure can. Part 1. The galaxies are much older and thus much further apart than the researcher initially estimated. Now, instead of the expansion you did before, make each row or column 1 millionth. Oh, no. Sweet. In the example above, if each row or column was merely 10 times larger, the sum of the shortest paths every pair of galaxies would be 1030. If each row was 100, and then they expanded, blah, 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 blah. Okay. Can I, without thinking too hard about this, do this? Entities. No. No, I can't. So we can't actually physically do the thing. That's the trick. That's what part 2 says, is you can't actually grow the grid. You have to figure out a way to do this without growing the grid. And I think I have an idea. If you have because you're just having to expand the for every row or column that's between your coordinates, you add that much to the what do you call it? To the distance. How do I count the number of numbers between those two numbers? Yeah. Let's do this. Let's wait a second. So print empty rows, print empty columns. 3 and 7 and 258. So how big are the numbers? I this, I do this, and I do this. Print, then That's not bad at all. Okay. Damn it. Close the wrong thing. I'm back. Four are in empty rows. If X going to be B at 0 minus A at 0 plus X offset equals 0 and Y offset going to be 0. So here there is a Y offset 1. Okay, let's do this. So 0, 3, and 1, 7. Yeah, there's a Y offset. Okay, cool. I think I have the gist of it. X del is going to be equal to B, well, it's absolute value of B at 0 minus A at 0 plus X offset Y 1 1 Y. So plus equal X del plus Y del. It doesn't. $370. This is what 0, 1, 2, 3, 4, 5, 6, 1. Five, 1, 4, 9, like I expect. 1, 2, 3, 4, 5, 6. does this all look right? But it's not. That's strange. There is multiple offset. And we should add what are we doing wrong? Think. Because it's just going to be, so 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, and then +1 for that. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 3. B plus 3. Why am I goofing so hard? Three, 4, 5, 6. Here, 1, 2, 3, 4, 5. 7, 15, 3 and 6, 17, 8 and 9, 5. Da. This is frustrating. To say the least. Why are we not getting the right answer? feel like it's just some little bug or logic mistake. I think this... I think it's this. I think I've got these backwards. Nope, wasn't that. These are the rows. Too many logic mistakes in my solution. I'm so close to figuring it out. I just don't know why it's... This should be 374, not 350, and I don't know why. And I don't know which one of these is wrong, because all the example ones that he provided are all correct. And I'm not sure which one to look at to try and find. Maybe this one. 1, 2, 3, 4, 5, 6, 7. 1, 7. Here. Or no. 1, 2, 3. 3, 7. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What is the bug? Where's the bug at? Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 9. I can't find my bug either. I thought I did edit. Yeah, mine works on all the examples, and I went to go start working on part 2, and my part 1, like, it's, I don't know what's wrong. 1, 2, 3. No, it's fine. I'll figure it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's ridiculous. Actually, here. This is what we need to do. This is what we need to do. We need to take this. We're going to think with our noggins here. We're going to take this right here. And we're going to... We're going to put that there. And then we're going to come back to this. And go back to the part 1 thing. We're going to get rid of that. We're going to get rid of that. Okay. Now we're going to take this again. We're going to take this. We're thinking. Just think about it. And we'll find the discrepancy. There it is. Discrepancy 1. 1 and 3. Why is there a discrepancy here? Oh, I see. I think I see it. Okay, let me think for a second. Think. I know what the issue is. It's sorting. That's the issue. Things aren't sorted. Because the dots are out of order. That's the issue. No, why is my cursor over there? Change this back to C. And 1. Fuck! I was so confident. Oh. Duh. Yes! Okay. We're getting there. Forgot to comment that last part back out. Okay. Alright, we're cooking. We're cooking. Let us cook. What do we do now? We need to grow the thing. The universe is expanding. Damn it. Why is that not right? It's too big. Why is the number too big? This is how many gaps there are. For every gap, we want... For every gap, we want to increase if each row or column are merely 10 times. In the above example, if each empty row or column were merely 10 times larger. So we are increasing the thing by, is it just increasing by 9? That doesn't feel right. It is right. Because it's just one less. Okay, so we're doing it by 1,000,000. But he doesn't tell me what it is per million. That's a shame. Alright, cross your fingers. Please, 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 please. Yes. Okay. 1 second. I want to see how bad I did. Sufficiently bad. Okay. Let's go back to the code. Sorry, I just like to see how... I like to see how I square up with my friends. And the answer is badly. Okay, let's talk about what we did here. So the first thing we did is we fell for the trap. It was a trap. It's always a trap. So let's go back to what the problem says. So the problem said that, okay, well, we have this universe, and any empty rows and empty columns, we need to expand those by an additional empty row or empty column. And the first big dummy mistake is that, or not mistake, but I am horrible at transposing 2D arrays in code. So I actually physically expanded the grid, which was mistake 1, because you didn't need to expand the grid. That was just silly of me. And so after you expand the grid and everything, you're finding the shortest path. You did the exact same thing. Yeah, it didn't dawn on me that you didn't need to do that until part 2. So you expand the grid, and now you're just finding the shortest path between all. I think it's 9 choose 2. It's the number of galaxies choose 2, if I'm combinatoricing right. You're just finding the Manhattan distance between all pairs of galaxies. I love how they give you the shortest path as this like overly complicated diagonal looking thing, when really you just have to drop a vertical, drop a horizontal. It's just the Manhattan distance. Expecting part 2 to allow diagonal movements, that would have I wouldn't. I'm glad it didn't. So once you do that, you're just looking at the Manhattan distance between all of the pairs of galaxies. Now then part 2 says, well, let me actually explain how think. So I've kind of destroyed my code. So we're just going to talk about part 2's solution. Part 2 says, instead of growing these empty rows and empty columns by an additional row or column, expand it by 1,000,000 by 1,000,000 rows and columns, which immediately that says brute force is gone. You can't grow it explicitly. You no longer have a physical representation in memory of what the expanded universe looks like, because that would just take forever too long. So what I ended up doing was figuring out, okay, where are all of the rows and the columns that are empty? And I know that those are the ones in which the space between galaxies is increasing. So once I know where all the rows and columns that are empty, so just, figuring those out by if statements and stuff, then I know that I'm going to have an offset by however many empty rows and columns are between the two galaxies, the X directions and the Y directions. My first bug was that I didn't have the order of the galaxies in a way that made sense. So my inequalities were all out of whack. So I min and maxed the endpoints to make sure that I was doing the comparisons in the correct order. So count for every empty row, you need to increase the gap between the galaxies in the X direction or Y direction. I don't know. Cartesian plane is hard. And same thing for the empty columns. You need to increase the gap between them. By the appropriate offset. And so once you have that offset, then it's just the Manhattan distance again, plus that increased gap, and then just add it all up. So that was it. Honestly, I think the hardest part was me trying to create the representation of the expanded universe, because I'm really bad at working column by column, and transposing and 2D arrays are hard. But once I figured out how to do that, even though I didn't need to, It was just implementing and then fixing bugs. Captain Station, thank you very much for the follow. So that's going to be it for day 11 of Advent Code 2023. It was a bit of a mess of self-created bugs, but we got through it fairly quickly. It's not 3 a.m. like it was yesterday for Advent Code. And we're going to be signing off. So thanks for hanging out. So thanks for watching the video. And I will see you all on day 12, Advent Code 2023. So take care.